Okay, good evening. My name is Eshan Rao, and this is the ninth session for programming in Java. And today we are going to discuss about Java generics. It's a next concept after interfaces and abstract classes, followed by uh, nested classes. So today we are going to try to cover these two topics as much as possible in today's session. So let me start by sharing my screen. I hope my screen is presenting right now. So let's start. So we will go with something called as generics in Java. So it's just a natural advance, the next step after abstraction or interface. So or classes. So like you have seen that what we do over a period of time, if we have some doubts, if we have some elements to discuss upon, you have some functionalities. So what we try to do is, if something is common, we create them as a separately, as a class, as abstract, or as interface, right? That's how the design methodology follows, that how we do, right? What generics do is, generic is just one step ahead of all of them, where now it allows to create classes, methods, interfaces, and all those same thing. It will work still in that way, but we don't have to much dwell upon the what kind of element it might contain. Okay, so example is array list. So as of in last few sessions, or also in the course, you have seen, you have also implemented array list a lot, right? And you have seen that I have to specify a type, particular type, whether it's a string or particular class object, like that, right? So how it is able to handle that? We are, even though we are specifying the type, and when we write the code, we specifically tell that we need this a string type or int type or float type or double type. We want that kind of input only. But when we are using something, someone like linked list or array list, we just, even though we just specify that okay, the string should be of my type, of string type, it is already accepting it. So how it is playing in the background, right? So that is something we are going to see today. So so that is a concept generic, that is, it allows us to support of elements, the data it should process, any class or record interface, it should support any type of element of whatever type properly, right? So that support is given by the generics. Now it is also, it comes in Java records interfaces. We will look at mostly at classes level. So let's look into that. So how it is differentiating, let's look into that first. So in a regular class, I have a class, I have a class name, okay. Then I have a field, that is we consider private string field. Now the important part here to observe is the string part. We are explicitly specifying that the field that we are passing on should be of string type, not of int, not of double, like that, right? Now, but I want to say that I don't want that specificity. I want much more freedom in terms of that it's on the go. I will tell that what kind of field I want. So at that point of time, generic class will come into picture. So here the how you can define the generic classes using diamond brackets, the class name, and then this is diamond brackets where you specify a variable or letter, in this case t. Let's say, assume that some type identifier, it's called as type identifier basically. Okay, you can use small t, capital T, anything, but for convention people use capital letters only. And then when you're specifying your field, you have to specify t as its parameter. So what it will happen in the runtime, it will look at that t, whatever the type of t will be. In this case, let's suppose string. If we pass string as a type, so it will automatically connect that this t is basically a string or int or float, just like that. Okay, so this is how we declare a generic class in this space. And basically at runtime, this t, which act as a placeholder, will tell the compiler that this is a type that you have to look into, and it should Now whatever the functionality you're calling into, it should be adhere with that particular type. Okay, now this is same. The field type is this placeholder. It means it can be of any type at all. T can be any type, be it primitive or non-primitive. The non-primitive, the one which you are defining. So I can pass any class object also as one of the type. Okay. Now, just for an example, how generic class work. So ArrayList is a type of generic class that we have just seen, right? So how it comes into picture. So usually we say class name, that the reference type, that array list, and we will also tell the name of the variable. But we haven't actually focused much on the type parameter. So as we in the last few sessions we have used this array list a lot, and we have seen that we can pass, apart from the primitive value, we can pass majority of type of parameter, even it's a object of any class, right? So this type parameter is changeable. So today we are going to see that how we can also do this part, how we can also tell the Java that I will not I will, when I'm calling the list of string, let's say array list, or any other function, I will on the fly I will tell that this what is the type of that list of string would be. Okay, so this is something we need. We will look at the generic type. Okay, so this is a kind of parameters type that we are talking about. Now, uh, most of the Java libraries that we are dealing with right now are actually written as a generic class only or generic interfaces only. Okay, so we will see that lot as we go more and more deeper into this aspect. Okay, so let's start with writing our own generic class. Okay, and then try to understand how it will help. So um, so I have already written the code and I have shared the link in the chat box. So whoever not got that code, please, anyone who has already received it, please put that again in the chat box. So lot of code is there, but let's start with the basic. Uh, so let's see that. So our intention of this code here is to show the generic is. Um, I have I want to create a team. Okay, so I will start with creating a baseball team. Let's suppose now I will try to create a baseball team with, say, let's say I'm having a team name. Then I might add the baseball players also, the players in that and all that. So once I have team, I want to extend it. So I also want to have extend that baseball team to different types, be it football team, volleyball team, cricket team, right. So how can I go to that level? I specified one class very specifically. Now how can I make it more and more generic such that I can um, put most of the values which are commonly there to much more ease. Okay, so let's go step by step there. So let's look at this. So first we are creating a baseball team. So let's look at the baseball team first. So baseball team.java, this is the team that we are having. So it has few variables. Private string, that is team name, that is what we are passing. This is list of baseball players. We will go discuss that baseball players also in some time. Then we have a few more fields, that is the team, how many wins it has, how many losses it has, how many ties it has. Okay, then this is a public this is a constructor, parameterized constructor, and we are just passing the team name, nothing else. Okay, now this is for adding team member. So let's not discuss here this part. I will come down to this, adding a baseball player. So I will come down to this part of code, but let's look at other codes that we are looking into. Okay, so this is also listing the team members. Once you have know that what are the baseball players I have, we just need to list it out. That is also fine. Let's look at rankings and set scores, because these two are one we are going to call right now. So ranking is if I have two or more teams, I will look at their total number of losses, not total number of ties, and based on that I will try to rank them. So the smallest ranking means that it is a top, that is first is the highest, and the higher the rank goes, the lower the rankings of the team will be. Okay, so that is the logic of that code here. Now set score here is if I have a baseball match and I have providing two scores there. Okay, of two teams. So first is outscore, that is, let's say I'm in the one team, so that is outscore, and the second is their score, the another team score. Now what I'm doing is I'm just returning a message telling that uh, so by default I have given a message lost to, but if our score is greater, outscore is greater than their score, I will just say that for that particular team for which we have called this, their total wins is plus plus, and message we will take it as beat. Okay, if it is equal, that is we are just tying the number of out of all the matches they played, the ties we have added as one, and we send the message tied, else total loss plus plus. Okay, and then just two string method, we are just telling that team name and how it is ranking. Okay, so these are the few basic functions of baseball team. Let's go to the main function again. So let's see how it is happening. So here a baseball team we're defining, and its object name is Phillies 1, whose name is Philadelphia Phillies. Okay, so we're just invoking this constructor, invoking this highlighted constructor where I'm asking for team name. Okay, then I'm also creating another team called Houston Astros with the name of Astros 1. Now what I'm doing is I'm calling function called score result, where I'm passing the object Astros and Phillies, and also passing the score, how much they score in that baseball game. Now let's go to the score result and let's see how it will work out. So our focus is first part of the code. The rest part of the code will come to that, because there are three different variations of how you can write the code, and that's what we are going to see here. Now the score result asks for four parameters, and that we have passed, that is baseball team 1 baseball and their score, baseball team 2 and their score. Okay, so we have done that here. So baseball team 1 Phillies 1 their score, baseball team 2 and their score, and then using team1 object we are calling the set score function, and we are taking the message. Okay, and then since this is the object of team1 only, I will if based on the if it's winning or losing, I will increase my total win, loss or ties, right, and from that I will get the message. That is fine, but I also need to update for team 2 also, right? So that's why I'm again repeating it, team 2 set score, because irrespective of there's only one team to win, so we're just reversing it, T2 score as first and T1 score as next. So let's suppose team 1 wins. So here the team 1 will get one win, and the team 2 has to say that loss, right? So that loss, for total losses to be get calculated, we are passing this team score and just printing it out. So if I just run this code, so so we see that Philadelphia Phillies lost to Houston Arrows rank 1. So that's how we have printed it. Okay, so this is running perfectly fine. It's telling that who win, who lost and all those stuff, right? Now the same thing we will do. Now we want to make it more generic in nature. Now we have done it, that now I have baseball team is there, now I can do it, right? Now what I want, that I want to make it a sports team. I don't want to explicitly specify which team it should belong to, right? If I make it more generic, how can I do it? So for that, let's look at, so there are two ways to look into it. So first part is I can create a duplicate code. Okay, so I will create a baseball team, and let's say I want to create another team called football team. So most of things are same. So I can create that, but the problem is if I change something to baseball team, it will not reflect in the football team, right? Or I have to be very cautious about that. Whatever changes I'm doing in baseball team, I have to do it football team. So it's not a it's not a recommended approach in this part, right? Another recommended approach that we have already seen here is use interface or abstract class. Okay, so I will create an interface called players. Okay, I have a thing called team. which try to, and the baseball player and football player try to implement this interface, and this team will be related to the which implementing this interface. Okay, so this is a much more higher abstraction where I know the certain functionality I have to be keep upon, so I will extracting using with the help of interface, so I will use that. So let's look that aspect into this code. So if we don't want to duplicate it, how we can do it? So first look at the duplicate code part also, if you want to do little bit. Now sports team is there. This sports team is exactly like baseball team. It has its team name, uh, total losses, total ties, and all those stuff. But now what we are doing here is we are adding an interface here, which is called as player. So the player interface we are defining in main.java, and what we are telling, we are just telling that interface.player and string.name. That's the only thing we are defining. Nothing else. It's abstract type name function. Nothing more in that. So let's go to sports team. Now when we go to sports team, the code will, if you look at it, it will same as the baseball team. Only difference is here instead of baseball player, we talk about baseball player also. It has an interface called player. Okay. uh, Now it has public sports stream, which is taking as a constructor. Okay. At team member, list team member, we will talk about it, but the rankings and the set score is same as earlier. Okay, everything is fine. And then the same toString method also is there. Now if I try to run this code, Philadelphia Astro and Houston Astros. Now what I have to do here is the only difference will come in score result. Everything is fine, but difference will come in score result. So what is it? Let's see that. So I will just go to score result. So what I am doing here is I am doing a kind of method overloading. Okay. So everything is same, only the parameters. Instead of baseball team, I am making a more generic sports team here. Okay, and then from there I'm passing the score and I'm getting the results. So if I run this code also, the code that we have seen earlier, it will be same as earlier the baseball team. Okay, so we have made it more generic as of now in this case. Why? Because we have a player interface with respect to us. Okay, so let me run this code also, and let's now talk about what else we can add in this interface. Okay, by the time it is running. Now if you want to be a more about specific player type, then we can talk about, apart from baseball team, we have to talk about baseball player also. See, the results are same as it is. Okay, so let's talk about that first. Record. So we are taking a record, we are asking for name and position, and it implements a player. So if I am passing a baseball player or just a player here, and I'm keep on adding the members, which I will do right now. It, since it implements a player, I can add the baseball player or beat football player. I can do that. So let's do that part also. Okay, now to make it more generic here, apart from sports team, we are taking another theme called team. Okay, now here we are adding few more things. Now it comes down to generic class. So we have seen the interface part. Now we will look at the generic class here. So what here we will try to do here, here is I will ask for a public class which is called as team. I will tell the type of player it should have, or type of team it should have, which extend from a player. Okay, and the how it will do that, that means the record that we are generating right now for football player, baseball player, volleyball player, which implements this player interface, right? That we are looking into. Okay, so we are extending those players. We are asking for same as team name, but only difference is earlier we have had player, or we are very specific, either player or very baseball player. Now we are doing T, directly we are not specifying exactly what it should look into. It has to identify on the go. Okay, so this here the generics come into picture. I'm not explicitly specifying. So how, where I will specify explicitly, I will specify only when I'm creating an object out of it. Okay, so here I'm specifying that the player has to be a baseball player. Now what is affiliation here? So affiliation, we are just telling, we're creating another record in team.java. We are just telling that what is the country type. So given a name, type, and the country code, we're telling that from which country that particular sports team belong to. So that is affiliation. So so we are specifying the generic in this. I'm specifying the generic type baseball player. I'm telling the affiliation. Okay, I'm creating an object name. So here the generic will come into picture, and then I'm telling what is my team name, and also since I have to in the constructor I have to pass affiliation also apart from it. So this I should keep it here. I'm just highlighting this part. So affiliation, I'm telling that city, the type, and the country code. Okay, so I'm passing the team name as well as the uh, from where it belongs to. That is one. Similarly, second is baseball player affiliation, and I'm just passing the team name. Okay, there are two constructor are there. Now, interesting thing here is this is the first example that we have saw is just a basic class that we have seen already. The second type we are looking into is using of interface, where we can specify explicitly the kind of sports team we want. Third, we are getting more generic. We are using generic, where here only I need to specify the type of the player I want. From that, it will take care of all of the rest of the things. Even we can look at the score result. So this particular part, line 63 to 69, here we are looking at the generic thing. We are very specifically specifying the which kind of team we want. In the second type of score result function, method overloaded, we are telling a sports team has to be this. Be it football team, baseball team, it will be fine. In third, we are going much more granular and telling that oh, there's a team. Now I have to specify only in the main function what kind of team it should be, and rest of the thing will be taken care by it. Okay, all the code written here that I will use set score function to add how many win losses are there. All thing will be taken care by it, but the main thing is the team aspect here. Okay, which we are trying to create using generics. Now if I run this code also, all three different methods, but it come down to same way, that how it is calculating the output. Okay, that's what actually we want. Three different ways of defining a particular type, uh, uh, the particular type of players or team, and based on that you extract out the meaning out of it. Okay, so that's the power that Java is giving to us. Now let's add few more things, that is add team members or list team members. So it's basically about if I have a baseball player, football player, how can I add it to my particular team. Okay, that is something we are looking into. So to make this, we create using record. So it's a baseball player, it's a record, and if I work on hover over my var Harper, so Harper is a variable and it's creating a baseball player called B Harper and its particular position. So you can check it that I don't know if you can see it here, I'm highlighting, it's a record of base player which extend the record and implements the player. Okay, similarly I created another variable object for another baseball player. Now I'm adding that to a baseball team here, and then it should and it is trying to it will add it. Okay, so let's say I'm just put this down for now and trying to list it out. So if you go to the actual code here, the add team member will look into this, what is the kind of player I have, whether it contain, if it already contains player I will not add it, if it doesn't contain a player I will add it, and afterwards I will try to list out that what's my team members are. Okay, So it tells about the team name, its affiliation, and also the team members you have, right? Now, if we want to add something as different, let's say instead of baseball player, I want to have football player. The football player is a kind of record that I am already having here. Okay, so it should try to specify that I have. It should not actually add it because I have already a baseball team, right? So if I just run this, it's already showing compiler error that if I have a baseball player, I'm providing a football player type. Okay, and that is happening. If you can look here is change first parameter, add number t to football player, something like that. Okay, so it is showing here output as a generic, that because I have to specify the specific type of football player that I want. I have to specify it openly. So add team member. So if I here I'm adding t here. Okay, this t is already a baseball team type, so I can't change it. It's already a baseball player type, so I can't change it. So but if I am not, if I make it as specific as football player, it again an issue will come into picture because it already has certain predefined value here. Okay, so I'm reverting back to the changes, but this type checking, it's possible because of this generic that we are trying to create here. Okay, so that is what I want to say here. So let's convert to the baseball and we will add it. Similarly, if I want to, sorry, let's remove this. So if I, instead of I create a football team with football players and all, with particular team of Adelaide Crows and the affiliation with respect to it, and I've tried to add it, it will also work it out. Okay, similarly we can add new football players with add afc.add members and list. So here I want to add make it little bit aspect here that with the team thing. Okay, if you look at the Phillies, it's a team type. Here also with the team type, I'm creating a new team called football player. Okay, and similarly, if I add a volleyball team in this case, like Adelaide, this is also a team type. Okay, so using the same class called team.java, that is a generic class, I can add three different type of player, football player, baseball player, volleyball player, and it will take it out automatically, and it will show me that how the output, it will differentiate between different kind of outputs, different kind of inputs that looking into, and also it will also look at that which one is compatible and which one is not compatible. So that is also it's working, you know. So if I just run this code, these are some listing members and printing statements. So I just run this code now. But I hope you get some clarity about the generic, that it's just a one step ahead of the interface abstract class, where you don't have to be worry about that or you have much more flexibility about what kind of uh, out sorry type of variables that you want to print it out or you want to pass it through, and it will differentiate between each of them properly, and it will try to show you the result accordingly. Okay, so that's about the generics as of now. The reason I've covered this generic because in nested class or comparing you will see them very often over the period of time. So if do you have any questions with respect to generics as of now? Any questions with respect to generic that you have? Okay, topic is a volleyball team program. Okay, so nothing different from whatever volleyball team that is happening, right? So there's nothing different from whatever we have done for baseball or football. I'm generating a team which should contain a volleyball player and it should have a certain affiliation. So I'm creating with an object. I'm creating a team only. Why it can take? Because it's a generic type and I'm not specifying explicitly here anything about what kind of team player a particular object should consist of, right? So that is this T generic that we are doing here. Extend player and S, that is something is taken care of automatically. Also there's something called as upper bound of generics, which tells that in this case players, the player which is an interface, and all the associated subtype classes which are extending or implementing this interface can only access it. So if I have something new class which doesn't implement a player which is an interface, it will not work. So that is something we are also specifying that to the limit that only what kind of objects should only access this class. That is also we're trying to specify it very explicitly. That is the one thing. Any other question? I hope you get the answer of this. See, the volleyball team, football team, whatever you're creating is same as the baseball team here. Nothing much difference. Only thing I want to show that with the team generic class called team, you can create 3 different type of players easily, and Java will differentiate them automatically. Okay. Um, okay, so if you have any other question with the generic, please type down chat section. Otherwise, we'll go to the next part, which is building on top of the generic, that is comparator and the comparable interface, because we used that earlier also a lot for sorting method. So we will see that part here as well. So this is generic parameters that we have talked about. This is how public class will be with the name and also the angle brackets and the type that we want to, the type parameter that we are having. You can pass multiple parameters that we have seen earlier also. Okay, this is the bounding limit that it can be bounded to extend player, that is any subtype of a player which is interface in this case can be accessed this parameterized type, because it works on the concept of inheritance as well. Okay, now we are specifically, now let's look at the sorting part, because it related to the both interfaces as well as the generics. So we are just going to cover small portion of comparable and comparator aspect here, so just to look into. So when we call array.sort, which we have done a lot in this particular last few sessions, we just pass an array, right? But it also we also actually need to implement a comparable interface also. That we'll see that why do we need to do that, because it is like when you're extending it, by default it is taken care by the integer because of primitive data type. But when you have your own object and it has set of fields and all, at that point of time you can't just do array dot sort. You have to be much more you much more have complex mechanism where you want to sort it to according to your need. At that point of time, this comparable interface needs come into picture. Okay, so how the comparable interface look like? It's a very common interface. It's similar to what you have done with toString function or the constructor. So this is the common functionality that we look for printing a particular object. ToString for any class and object, any object, it's present in every object. So similarly, comparable is also available when you're trying to use it for comparison or sorting. So the interface declaration is public interface comparable, and here this concept of generic will come into picture, where we have to specify what kind of object or element we have to pass into. Then there is a function called int compare to, where we'll pass this particular type of parameter object here. Okay, so it's a generic type, it is parameterized. Okay, any class which implement this interface needs to implement compare to method also. Now when we do array.sort, we have some wrapper class called integer, double and all that. They by default do this, so we don't have to do, but now we are reached to a stage when we have to write our own classes and object where we have to do a lot of complex performing. There we need to explicitly say about comparable function as well. Okay, so it is some few aspect of comparable interface. So when we call this compare to function, and so what it will take is it takes one object as an argument, okay, and it compares it to the current instance. So I will just call a particular, I have an object, and from that I will try to compare it with some other object from which I am passing. So that's why the object which is calling this will be the current instance, and the one I am passing is the one as an argument will be the another instance. Okay, so it will return me three type of value. If the resulting value is 0, that means they are equal. Okay, negative value when the current instance is less than the object, and positive value is when the current instance which is calling this comparative function is greater than the argument here. Okay, so these are the three output that I to give. Now okay, comparator will come down to that shortly. It's another way of writing this. So for this I have another project called comparing.java folder, comparing folder. In that I have a main folder, it's a one file. So I have shared that code also later, so you can check in that folder as well. Okay, so let's look into this. Now let's say I have a integer of a, this is an integer is of a particular class. It's not an int value. I have named it as 5. Okay, and it's 5. Okay, some it's here auto boxing aspect. I hope you remember the auto boxing aspect. So here auto boxing is happening, that is here the value int is converted into integer wrapper class. Okay, now I have, from this only I have integer wrapper class as a array where I am passing these values. Okay, so I have 5 values which I am passing out here. Now what I will do, I want to compare each of them. Okay, so how can I do? So I'm using an enhanced for loop, so integer I and others. So this is an enhanced for loop, and what I'm doing here is I'm calling 5, which is a current instance of integer wrapper class. This is a current instance, 5 is a current instance, and we are passing I, which is a integer part only. Let's say 0, 5, 10, 1 by 1. This is the value we are passing as an argument of that type. So we will try to compare the 5 object and the ith object of the integer wrapper class. Okay, and that value we will store it here, and we try to print it out that if it is 0, then what, if it is less than or greater than less than 0, what, that is what. So if I try to just run this code, okay, so this is was my object, 5 was an object, and one by one I am comparing them. Okay, so 5 is greater than 0, the value 0, 5 the object 5 is greater than the value of object 0, integer type, so it is saying 1. If it is equal, it is saying 0. If it is less than the current instance is less than the one which is passed as an argument, it is -1. Otherwise if it is greater than that, it is positive, otherwise negative. Okay, so here what we have seen is this integer, or let's say string also. Let's look at the string type also. Here the values will be something different. Here by default the comparative function has been created. Okay, and if you can see that and when I'm hovering, it is saying that it is a type of java.lang.integer, the integer wrapper class. Okay, so integer is in interface of comparable, so that is also is there. So they are doing it automatically. Okay, so these are the few examples I'm trying to show that which is already there, and you can, when if we are dealing with integers or strings or floats and all, you can directly use comparative function when you're comparing two values, right? But there is some cache to it also. So let's look at that. So for that we have a string called banana. Okay, now we have a array of string which is called name as fruit and which has apple, banana, pear, and the banana in a capital letter. So similar processes above. We have a banana which is a individual variable string we are passing as a current instance, and we are calling comparative function, and we are passing these values apple, banana one by one, and we are trying to see that how the values will be. So if I just run this code, okay, so here I'm highlighting the output. So here something different is coming. So when you're comparing banana is less than apple, is showing 1. Okay, banana equal to banana 0, that is fine. But banana is less than pear, so it's showing minus 14, and banana greater than banana is showing compared to 32. Okay, so here the values are instead of 1 0 or minus 1, which we saw earlier for when we shown slide or in the output also earlier, it is showing like this. But why the values here differing? Okay, so here it's come down to the value of ASCII values, where it is when it's checking to compare two function, it is only checking the first letter here. So ASCII value of b, small b, and ASCII value of capital A, say small a, and checking its difference. Okay, so even let's do like this also. When we do array dot sort fruits, okay, if we just do this for a string, you can see that output, the last line, that capital B banana is first, followed by apple, banana, and pears. So how it comes down to this? Because it's looking at the ASCII value. Okay, now to show it much more clearly that how what kind of values are we dealing with and how this upper values come into picture, uh, we just wrote a code there where we are just passing for capital A what is its equivalent integer value. So for a particular character, what is the integer value? Small a, what is the integer, its equivalent integer value. And then if we try to see it, we will might get understanding that how the actually process is happening in the backend. Okay, so if you can see that I have we already seen this part multiple times, but capital A is 65 ASCII value, small a is starting from 97, capital B is 66, small b is 98. So difference between 66 and 90 is 32. So when it's comparing capital B with small b's value is 98 and capital B value is 66. So when you minus it, when it's comparing, it's just having a subtraction and it is giving me the value of 32. Similarly, pear and banana. So pear value is 112 and 98 is the B value. So it is, if you subtract it, comes down to minus 14. So when you're using this function, you have to be aware that you can't just, if given a string function, you can't just use array dot sort directly. Okay, it will still, it can give you misleading results. So how do we resolve it? Right, so that's the question we are having. So for that, we will show it through a class. So in this same main.java, we have created a student class. Okay, and it implements comparable student. Okay, so that is something we will look into right now. So let's assume that this is simple class student. Okay, we have a static id, we have a random function. Now string name is there, int id, and we have a protected double GPA. So for a string, say for a student, when we're creating a constructor, its name, it will we will just pass on the name when we're creating the object. Its ID will automatically calculate it from the last ID. Since it's a static, so it is the same copy for everyone. So every ID a student is creating, it will be unique. Okay, and GPA value we are just doing it with random dot next double. So we created a random function here, which is a random object, which is also static. So when we are doing random dot next double, we are trying to calculate a GPA between 1 and 4. Sorry. Now when we are doing this, and we're just returning a public string format. Now when you're doing implement comparable, you have to write certain function also. So if I do this, uh, okay, so I just commented some code and showing red line. So what happens is when you implement a interface or something like that, you have seen earlier that you also have to implement certain of its method. So in this case, since we are looking at the comparative function, uh, so we have to initiate it. So I have already written it. So let me write that, uncomment that. Okay. Now here we are trying to define our function properly. So what we're doing, public int compare to student O, and then we are comparing name compared to name. Okay, so that is we are trying to do here, and let's see what will happen. So we have a student function which implements a comparable interface, and when you're using the interface, we have to define comparative function also, which we are returning like this: name compare to. Now let's create few code here. Now what we have done is I've created a new object called EAS with a student object with my name, and also I've created a array of student. Okay, it it has its own student values and all, but it also has other values like this, their ID and the GPA. Okay, I'm using array dot sort, and then I'm printing it out the student. So if I just do this, okay, so it is showing me uh, that when I'm doing compare to function here, so it is sorting my this values which I have written randomly. That is, first was Rahul, second was Devya, and third was Ishan. So now it has using the array dot sort student. In this case, it is showing me that it is done the sorting based on the name, that is DER, kind of like that. Okay, so that's how it is happening. Now let's do something else. Let's suppose you want to deal with the ID. If you want to do with the ID, not with the name, how can you do that? So what you can do is you can look at the IDs. So what you can do is the current instance ID, you try to find the ID, and then you compare with the object student o ID, and then you compare them, and based on that you can return the output. So for to do that, if I just run again this code, okay, now it is sorted according to the IDs, what, like 101, 102, 103. Okay, so that main thing is the compare to function can be modified according to your need, be it by name or be it by ID or be it by GPA as well. Okay, so for GPA we will use some other thing. Um, Also a few checkers that I want to show you, some few mistakes here that can come. So let's suppose you have passed, uh, I have an object called EAS, and then you want to pass compare to function for that, and you pass just a string. So it is showing directly a red line error. So if you just check it, so it's saying that required type is student but provided is string. Okay, so that why that is because when we are using comparable, when we are asking for comparable, we are explicitly specifying that the type should be a student. Okay, not string or nothing else. We have to specify explicitly student, that's why it will work, otherwise it will not work. So that's why the error is coming here. So let's comment this part of the code, and if I just write compare the two student, that is the name with my name and especially with the uppercase one, it will show me the result differences. So if I just run this code, so it's showing the result as -1. That means uh, the current instance of mine, that is Ishan, is greater than the full capital letters of Ishan, which is makes sense because by ASCII value I want based on the ASCII value thing, I want the capital small a's, a, s, h, all these values are bigger than the capital ones. That's why. Okay, now let's do one more thing. Apart from comparable, that is comparative function, there is something called as comparator. Okay, so let's talk about comparator first. So comparator function is similar to comparable function. Okay, but there is a slight difference here. Okay, so slight difference here is name. First of all, you pass as a generic type only, but here instead of compare to, there is a function named compare only, and requires two objects, not one. So it takes two arguments. So here it will like comparable, just look at the one the function, the object which it calls, as well as the one which has passed into. But here compare function, we have to method, we have to explicitly pass the two method to be comparing to. Okay, so what we are doing here is we are creating another small class called student GPA comparator, which implements comparator and should support the student type only. Okay, now when we're doing this, we have to specify the abstract function here, that is compare, and we explicitly specifying that the type of that particular object which we are passing to, it has to be type of student. Okay, and when we are doing this o.gpa1 o1 name the gpa2, it compare to function, when it do the compare to function, it will uh, put out the values. So let's say, okay, now if I just run this code part of this, so I'm creating an object called comparator, that is this comparator student of student type GPA sorter of a class called student GPA comparator. I'm calling this array.sort. Here something you will see something new. I'm passing the student the string value, the uh, string of object of student type, and also passing the type of comparator I'm dealing with. So I'm passing extra value here. And then it is calling this GPA sorter, and then it is printing out the values. So here the output is this. I'm highlighting in right now in the output box. So what is happening here is it is comparing the GPA, that is 1.66, 2.373 and 3.50, and it is all doing that, it pushing that as a ascending order. But if you want to do reverse order, you can use reverse dot function also, which is a part of comparator interface itself. So if I run this code, you can see that the values now are getting descending, that is highest to lowest. So it is like this. So it is showing highest to lowest. So it has been assorted like this. So uh, so the main difference between the comparator and comparable, let's look into that aspect. These are the common two functions which you interfaces which you will use for comparing your objects using either specific field or multiple fields like that. Okay, so in comparable, the first one we have seen, it compares the argument with the current instance, but it comparator takes two argument. okay, of the same type. Now uh, call the instance of class that instance implement the comparable. So the instance which from which you can call this has to be of same type. So in this case, when we are doing student uh, and it implements a comparable, that means I have to, when I'm calling this comparative function, it has to be of student type only. Okay, I can't use any other type. Uh, Best practice for compare to is equal to 0, which equals to being true, that is fine. In array dot sort, uh, in array dot sort function, we just need to pass the elements only of the type which we want to use it as a comparison, and afterward we when we want to sort it. But for comparator, apart from the elements, the type that we want to sort, like student, we also need to pass the comparator, the object of the comparator. Okay, based on that only it can sort a particular type. Okay, so that is few thing. And also one more thing about comparators, it doesn't require the class itself to implement the comparator, though you can also implement it in this way. So we have created a specifically class for it, uh, different class, but you can in similar way you can create its own object later, and then you can pass it down, and then you can use it in array dot sort function. Okay, um, so these are few little bit advanced topics with respect to the Java generics and comparators and comparable, the interface, which are interdependent on each other. And now based on this, we will look at the next inner classes or nested classes in the next part of the session. So if you have any questions with these two topics, please let me know, or any other topic, please let me know in the chat box, or otherwise you can unmute yourself as well. So comparing, it's at 7, it's already 1 hour, so we will take a 5 minutes break. Yes, anyone has question? Okay, so we'll take a 5 minutes break now. So let's say 7 o'clock, right? So 7:05 will come, and then we'll start for the nested class. So yeah, we'll go with the nesting class part, and we will see the 4 types of nested class here. So let me see if you have any questions here. Okay. Okay, so we'll come back at 7:05. Let me put that in chat box as well. Okay, so one comment is there: while explaining an example, please delete the previous explanation. Uh, okay, the reason I can't do that uh, is the lot of code which is interlinked to each other, and then I have to keep on fixing that part, that if I remove certain part of the code, then how it will affect it. So that's the issue. The other approach is that I will just type it out, and then while typing it I can explain it. That will have much better, easier flow, but that's a very slow method. I can't cover much topics at that point of time. So if I like same example of generics and comparator, if I do this, it will take the whole 2 session, because while writing type, even the how fast I type, still typing will take time. So that is the issue with respect to into it. If you're still facing finding it very hard, then what I can do it from next session, uh, I can still start again the typing part of the code. Flow will be much better, but it is very slow comparatively. So that's the issue with respect to it. But let me know your options, that which way you want to go. I can again start the typing part. I will, while typing, I will try to explain. Otherwise, little slower, I can cover few concept, but here I can cover more concept because I don't need to type. I just need to run the code and just explain it out loud. Okay, let's start the session again. So let's start with the nested class. Okay, so yeah, so nested class or class within another class, right? So this is a common topic, common aspect after when you deal with all the kind of oops concept, or the kind of data types you have, array lists and all the stuff. We come down to this nesting class, right, where you're trying to create a class and within another class, or a class within the method, right? So why do you need a class, nested classes? So when you're tightly covered, when that means you want to separate the functionalities between separate classes, but still you want that it should be within the access of that class which is calling it, right? At that point of time, uh, that functionalities should be will be interwoven at that point of time. That's why you need a nested class. Okay, so the other outside class can't access them. So that is the main reason of nested classes. The four type of there: one is static, another is inner class, local class, or anonymous class. Now till JDK 8, the static nested class and anonymous class, I think they are supported. uh, I think so local class, but I'm not very sure. But afterwards, till from JDK 16, all the variations, all the types of this are supported. Okay, so we'll look into this one by one, uh, and see that, try to understand its variations. Okay, type, if one of the things typing will be easy to understand. Uh, okay, maybe what I can do here is, uh, okay, bear with me for this session. Maybe next session I will again type it out. And let me cover this part of the nested classes. Maybe from next type I will type it out the code, uh, and cover the things much more smoother. Okay. Next time again I have to calculate Java collections only and lambda expressions. So I will do that at that point of time. For this one hour, just try to bear with me with respect to it, and please, I've shared the code also, to keep looking at that code also if you have any doubts regarding it. Okay, uh, so okay, so we'll try to understand the nested classes one by one. So we'll start with the static nested classes. Okay, so do this. We will created a class called employee.java. Okay, so in that employee.java, uh, let's look at the class later. Nested class, we have employee id, name, year started. We have a constructor. uh, we have a parameterized constructor where we are initializing this employee ID, name, and year started. Have a getter function. So it's a getter function, and we have toString function, which is by default for any object that we're having. We're just passing the employee ID, name, and year started. Okay, these are basic class that we are having right now. Now let me comment at the part of the code first. Okay, so what I have done is I have created an array list in this case. Now this list, array list, I'm passing it off with values. We're using the function called list.off. In this I'm creating a new employee object. I'm passing this employee ID, the name, and the year started. Similarly I have done as 5 records. Okay, so this is if I just run this, it will work pretty much fine. And some issue. Okay, so if I just run this code, it will work pretty much fine. It will initialize a list of employee called employees, which is basically an array list. Array list is a subclass of list, so that's why we can do this. It's come under Java util collection. Okay, so it will work and no output will be generated as of now. Okay, so all this thing is fine. Now let's go a little bit deeper and try to uh, create a static nested class. Okay, so now what we are trying to create a first part type of inner nested class, which is called a static nested class. Okay, concept is simple. uh, we are trying to create a class which is static in nature. That's it. Okay, so how we are defining it, now we are using comparators. So the comparators that we have seen earlier with the help of in the last session, comparing two objects, so we are using that. So we are creating class called employee comparator. It's a generic type, so we are explicitly not specifying what type of it should contain. It should figure out by its own, and it extend employee. That means any class which inherit employee can use this function. Okay, can use this comparator, and also it implements comparator, which is a interface that we have seen earlier few minutes ago. And only the what kind of objects it can accept, only the type of object called employees. Okay, so this is the static nested class that we are trying to create. In this we are specifying the sort type, what kind of on which parameter we have to sort. So by default we are sorting an employee based on its name. Okay, otherwise uh, we can specify explicitly that using employee comparator that what kind of sorting we need. Let's say year started, so we have 3 parameters in main.java, right? Employee ID, we can sort the employees based on ID, based on name, and based on year started, right? So any of these we can do it, so we are making it little bit more flexible here. So since it's a comparator, so the compare function will come into picture. If it is comparable, compare to function will come into picture. Now I will pass, since a compare function I need 2 arguments, so employee object 1 and object 2. Then it will look, first it will look at the type, sort type. So let's say if it is year started, okay, so it will look at, it will sort based on the which one joined earlier and which one joined later. So it will look at the differences between that. So it will check the object 1 year started and object 2 year started, and based on that whatever the value will be, it will pass it on, and that will be used as the parameter for comparison. Okay, otherwise if I don't have the sort type as year started, by default I will use name as parameter to compare. Okay, so this is the comparator functionality that we are trying to do. Now what I will do is, now if I just try to call this employee comparator directly, create this object and do this, it will not work. Okay, because required type is comparator. It's not, so it doesn't know the it doesn't know that it's, we know that it's under the employee class, but the Java compiler does not know that where it belongs to, right? So we have to when we are creating its object, the comparator object, we have to tell it explicitly that on which object we need to create, of which class it belongs to, or which object we should create to. Since it's a nested class, if we directly create it even though static, it will not work it out. So how can we do it? So for this, the solution is employee.sort. When we're doing this, we create a employee.employee comparator. So it is like a static class that we're doing it, right? We don't have to create an object directly. Using new keyword, we will create an employee uh, dot employee comparator. That's how we call static class. And then we are just tapping as one of the constructor what kind of sorted type we need. Okay, so that is thing, and I can just remove this part for now. Okay, if I just part this, and if I just print out the employees, these employees, so if I just run this code also, so what we are doing is, here we are trying to create an object for employee comparator, which is a static nested class. Now we are using this comparator directly within the employee.sort, which will take employees, this list, array list as the parameter. We're trying to sort it based on the type of year started. And here we can see that it has it has what is sorted it based on its year type. Okay, now if you want to sort it based on the name, I can just pass it out as empty, and if I just run this code again, here you can see the middle line here where the names starting from C and ending at R. So that's how by default it is comparing it based on the name. Okay, so this is example of static nested class, a class which you are defining within the class as static, and you are trying to access it without creating you're creating directly without creating an object using new keyword called employee.employee comparator. Okay, and then you're printing it out. So this is a static nested class. So let's look at some other type of classes also. For that we have to look at store employee. So for that, let me uncomment few parts of the code. Okay, so we are creating a store members, a store employees as a class. Now it has uh, four fields, that is employee ID, the name, year started, as well as the store in which it is they are working on. Okay, so I have five information of this five IDs based on like that: employee ID, name, year started, and target. As usual, the store employees, it's an array list. So store employees, the object name is basically a part of an array list. So let's look at the store employee.java class. So it extends the employee. Okay, here we are just having one more parameter called store. Rest of them it is taking directly from the employee. So here we are doing public store employee and calling the super constructor, and we are storing whatever the value of a store is, right? To string we are just using for formatting the part. Now here we are doing something different. So here this part, now we have seen static class, right? So the one which is non-static inner class nested class are called as inner classes. Okay, and this example is an example of an inner class. Okay, so here the purpose of this class also same, that if I have to compare if I have to sort the employees, in this case store employees, in a particular format, how should I do it? I will use a comparator function. So what it does is public class, which is an inner class within the class called store employee. So I'm naming a store comparator, which extends store employee, t extends store employee. So whatever the class which inherits store employee can do use this, and it implements the comparator function. And when we are passing the value, it has to be of type of store employee. Now when we are doing comparator, we have to use compare function, and we are passing two objects of store employee. Now here we are comparing, right now I'm just passing one type of sorting in this case, like we are comparing them based on this store. So whatever the value of store is there, based on that it will try to compare. Okay, now if it is 0, so let's suppose that I have two employees where they're working on the same store, then what should I do? Then since it's the extended type, extending employee, I am also calling employee.employee comparator, which is a static nested class. So I'm calling static nested class, and here I am comparing them, sorting them based on the year started. So if two employees are working in the same store, if I have to sort them which one has to come first, then I'm sorting them based on the when year started. That means the one who joined earlier will be presented first. Okay, so we'll see the output also, and there here also calling dot static class dot compare, and in that compare function we are passing this object store employee 1 and store employee 2. Okay, and then we are returning the result. So this is a non-static nested class, from where we are calling the static nested class as well. So coming down to main method, so let's look at few things. So how we can try to use it. Okay, so one way is I, I try to use the store employee dot new employee character. Okay, that is one way. Another way, but it will try to give me an error that I can't directly access it. Okay, even though it will compile, it might not access it. So what is the next way? The next way is I will create an employee, generic employee of the store employee type. Okay, now using this uh, generic employee, I will try to access the store comparator. Okay, so this dot new store comparator, uh, that I'm trying to access the inner class, so I'm putting that as a comparator part. So if I just hover on var, it tells me that it's a public class of store employee the store comparator, the inner class that I'm trying to access. Then if I use store employee dot sort, uh, I have to pass this comparator as a parameter to say that I have to use this parameter, so it is comparator while sorting it out. Okay, so if I don't put it, I can't access the store comparator. So that's the thing. And if I just print it out, in that case, let's run this code also. So I'm using a enhanced for loop where store employees, the list of array lists that I'm having, I'm taking them one by one and then printing it out. So after store employees, it has been sorted. So I'm using this. Uh, okay, now uh, so the store members are there. So we have 5 store members, and using based on the comparators, we are now we have sorted them based on the store, the name of the stores. So you can see that it has been stored based on the names of the store, that is MTW, kind of like that. Also when you're looking at if there are two members which are of same stores, then they're comparing it based, it's calling the comparator of employee comparator, and comparing it and from the static nested class and checking its year. So whoever come first, join the first in that store, they will putting it first. Similarly, Walmart also, in Walmart, two employees are there, and but they are sorted based on their year. So that's how the inner class and static class can be accessed in this aspect. Okay, now to show you simple, there's another way to show the, now we have remaining two classes, that is local class and anonymous class. Now instead of using this, I will try to show in a much simpler way, such that we can look into the everything in the same eyes. So for that I'm using run methods.java. Okay, so in this nothing much different. We have an array list same as store employees that we have used earlier in main.java, right? Now we will try to call it one by one. We will use different comparators and try to see that how it will work. Now before this, if you want to create a local class, okay, so how we can create a local class, that is what I want to show you first. So the local class comes class within a method. Okay, now we have a main function which is a method. In this I'm creating a class. Now class I'm doing, the class is of type, name is name sort, it's a generic type, and it also implements a comparator uh, which compares the store employee values. It can only take store employee values. Okay, and it will now we are passing the compare function. In compare function we are passing the objects of store employee 1 and 2 as you have seen earlier. Now after this we are returning using the compare to function, where it's checking the names of the two employees, and then based on it has to sort it. Okay, so this is called as local class, that is creating a class within the method. That's a one way. There's another way, this is called as called as anonymous class. Okay, a class without a name. Now, how can you do this? The same code that we have written here in the local class, right? I'm highlighting right now from 26 to 32 line. The same thing we can write it as anonymous class also. So how we can write it? The same thing. What you're saying is, we are not writing class name sort implement, nothing like that. What we are doing is new comparator store employee. So we are just creating an instance class. It will and Java will automatically understand that by superclass or interface, in this case is comparator. And the difference here is, after telling this new comparator store employee, I am creating a body a body of the class, and I'm ending it with the semicolon. So this is a differentiator. Okay, so var c4, let's say c6, new comparator store employee, and if I do this, okay, so this will term as a anonymous class. So here the difference comes here is that after the body you have to put a semicolon. Okay, so that's the main thing. Now within this body, now you can write any function or any parameter similar to class. So here, apart from the function that we have written as compare, which is same as the local function, local class that we have done, we can also write it like private string job name, something like that. It will accept it. Okay, even in local also, anything with respect to classes, it will accept it. uh, but one thing that we have to keep remember, in local class and anonymous class, if I write public, it will give me an error. Okay, modifier public is not allowed. So let's say change to protector. Protected is also not allowed. So for local class or anonymous class, we don't have to specify explicitly that what kind of access modifier it has to be there for that particular class. So we don't have to tell it, it will take it automatically. Okay, so it's a package private, it's called as package private, that is the modifier it will look into. But we do, by syntactical thing, by default we don't have to specify the modifier, that what kind of modifier should be there for local and anonymous class. Okay, same code but two different way of writing it. uh, you don't have to write the name, sort, class and all those stuff. It will just compare it automatically. Okay, now to show different ways that how we are doing it, uh, this is for inner class, uh, this is for static nested class. The normal comparator, the same as the static nested class. Okay, uh, so what we are doing this, we are trying to the same function. This is the array list, and we have four classes which do the same thing. That is, uh, we're going to call a sort function, and we're going to pass this comparator. Using this comparator, it will try to sort this whole list based on the name of the store. Okay, so for this we are creating a function called sorted function, where we are passing the store employees, that the array list, and also we're passing the comparator. What kind of comparator do we want? Okay, now let's talk about sorted. Before sorted, another way of writing a sorted function as an anonymous class is, this is one, right? Var c4, uh, and I'm just passing out I'm just specifying the super class of that particular anonymous class, that is type, in this case comparator interface, and based on that it will take care of automatically. If you don't want to do this, another way is, when I'm passing, I can pass a anonymous class as a uh, method argument also. Okay, so here when I'm trying to create a comparator variable, instead of passing that, I'm creating an anonymous class, and it same code as earlier, but this is an anonymous class, and Java will take care of it automatically. Okay, so that's a difference I want to tell you with respect to it. Another thing is, let's talk about sorted function. Okay, so sorted function is it's a generic, so I can pass any type of values here. It return none, that is void. Now when we pass list can be of any type. This is also generic. What here makes difference here is comparator, then under question mark super t. Okay, and then we are passing comparator. So what this function, this comparator super t is, comparator quotient super t. Okay, so it is first, it is trying to find, this question mark will tells the upper bound, upper bound of the type t. Okay, so so I have to specify that what kind of variables can be accessed here, right? So in this case most of them are store employees, so anything, so what it tells basically here is, uh, question mark super t tells that any class, the class t, let's suppose there is a class called t. Okay, t plus any of the super classes which belongs to t, right? Using interference, using the inheritance. Let's say store employee is there, it is the inherited part of employee. Let's say employee is the inherited part of organization. So any super class which belongs to the which inherited the store employee, I can access it. Okay, so that is the super class t is telling that it's showing the upper bound of type t, that is, sorry, I would say lower bound here. So anything which is store employee and anything above those classes, that is the super classes of store employees, can be accessed. Okay, so store employee is the last part. So but if you want to access the lower classes also, let's say the one which access also the which has inherited store employee, at that point of time you have to remove this uh, question mark and super. This will also work pretty much fine. Okay, so this is something new aspect into this thing. Okay, so comparator, we are telling that stored employees and any of the objects which belongs to store employees from where it has inherited, let's say employee or something like that, there it should accept this. So we are passing comparator, bit anonymous class, bit local class, like local class that we are creating it here. Okay, inner class static nested class from employee, it should be accepted. So these two parameters are there, list and the comparator type. Okay, so we are also specifying that which comparator we are dealing with. So using comparator.string, we will let to know. And then when we're sorting it, we are passing the comparator. The list will be sorted after this, and one by one the employee from the list will be taken out and using enhanced for loop, and we're just printing it out. Okay, so if I just run this code, uh, run methods. Okay, so let's look at it one by one. So output for every one thing will be same, but what we have to see the differences. Okay, so everything has been sorted uh, based on the name of the employer, that is Bert, Joey, Marty, Meg, team. So B, J, M, M, T, kind of like that. So everything has been, no, some things are stored something differently, so we will look into that as well. Okay, so first is employee comparator. The first comparator that we have chosen, in this case C0, this is the first statement. Okay, C0, it's an employee comparator that is doing. So by default, employee, when you're using employee, this function, we are using a comparator here and it is dealing with it. So here we haven't explicitly specified anything for the comparator, but by default it can run into and it is showing it. Okay, so this is for employee type. Now second comparator in this case is C1. Now this C1 is of type employee. You can see the dollar mark and then employee comparator. Okay, this is a type of static nested class. Okay, this dollar is actually telling us that uh, that anything beside apart from dollar is basically an inner nested class of the type of employee. Okay, so that is also the one that the one we have defined here. I'm putting that in the code part. Okay, so this part has been invoked and based on that this comparator has been used. Okay, third type of run method is of inner class coming from store employee. Okay, so how do we know that? Again, you can see the dollar mark here, and store comparator in this case is a basically inner class that we define in store employee, and it's of type store employee. Okay, so let's look at here. The line I'm highlighting in the code right now, this is the inner class. I'm not putting anything static here, so it's a non-static class which is basically inner class. I'm calling this function and it is working pretty much fine. Only difference here is that this comparator deals with comparing the stores, what you say, the store thing. It compares the name of the store, not the name of the employee name. Okay, then fourth method, C3. C3 is basically a local class. A local class is of type of name sort. So this is a class that we have named name sort. This is a local class that we have created. So you can see that run method, which is a function from which we are running, dollar and then name sort. Name sort is coming. From that we are trying to call it, and based on that it is again sorting it based on the name. So you can see that how the compiler automatically, even though I'm passing C1, C2, C3 and all, automatically is trying to understand that from which method I'm trying to call it. Now for anonymous function it is different. when you're calling anonymous function, say anonymous class, my bad, anonymous class, when we're trying to call an anonymous class function, class which we have done defined here as a comparator. Okay, so here the output here is run method dollar and one. It's just written one and whatever the object address space with respect to it. Okay, it is also doing it, it is also sorting it based on the name of the employee, but here it's not defining any name, it's just passing any number into it. So what is the anonymous class number? Similarly, the last comparator that we are having it sort employee store employees thing, there also the new comparator we are defining on the fly, on the go. So here in the last comparator also run method, the class name, the anonymous class we are it naming as $2. Okay, so these are the few methods where all the classes will do the same thing, that is it create a comparator class compare function, and using that compare function, when you passing at a sort, it will sort it based on the comparison function. But we have defined it in 4 different ways, like static, nested, inner classes, local classes, and anonymous classes. Okay, so yeah, I think I have covered whatever the things that I need to cover today by this time, quite early. But in short, so what we have seen today is, so there's something called as generics, where the task of creating a generic class is you don't have to specify explicitly when you're while you're writing the code for that class. You don't have to specify that what kind of type I will get it. You can specify it when you're calling that particular function, right? Example is array list or linked list or list. Okay, the same way we have seen the generics here, uh, which how can define it, public class, the name of the class, and then in the uh, diamond brackets you have to tell that what you have to specify the kind of names of the particular types that you need. Also you have to tell that whether it's extending any class or interfaces or not. So this is called Java generics. Comparator that we have seen throughout is this comparator or comparable is the interface which we use as one of the criteria when you're sorting a particular type of record or object. Okay, so using comparator comparable we can do that. So comparator has compare function and comparable has compare to function. Okay, and how you can use this as a parameters for sorting, right? We use all this thing in the sorting part, especially then building on these two topics of generics and comparators or comparable, we try to look at the nested classes, that is static, inner classes, local classes, and anonymous classes. Okay, static class is just a class within the class with the keyword called static. Inner class is a class within the class where the non which it is non-static. Local class is within the method, class within a method, and anonymous class with no name. It is also, it can be within the method, within the class, anything is fine. Okay, so these are the few topics that we have covered today as of now. Uh, from what I have covered today, this is from what I have to cover today, this is the things. The next sessions will be mostly on Java collections and the Lambda expressions. So if you have any question with respect to it, please let me know. Um, Also, if you have question for any other topics that we have covered till now, if you have any mm, question with respect to it, you can also let me know right now. Yeah, the class is over from my side as of now. Today we have ended a little early, but you can tell me if you have any doubts with respect to any of the topics that we have covered today. Do you have any doubts as of now? You can unmute yourself and you can tell, or you can type it out as well. So next time what I can do is I will again start typing it out so that it might be better easy to understand. I can understand these are little advanced topic right now. If I just explain it might go overhead, but please take your time. I've shared the code already. Take your time to understand the code, run the code, tweak the code. You might get it much better understanding over a period of time. Yeah. So any questions as of now? Okay, so in that case, I will take it as no questions for this session. So thank you for joining. So next section, we will talk about Java collections, Lambda expression, if possible. I will also include the try and catch the exception rules of Java as well. Okay, so yeah, that's it from my side. Thank you everyone for coming. Um, if you have any question, please let me know. We still have time. Okay. Otherwise, the session is end from our side. So I'm ending the call for everyone. So thank you so much.